Hello, welcome to the power of a power. I've got power. So what we've got is a situation that when you are raising a term with a power to another power, in other words, like we can see here, a to the power of m, then again to the power of n, it's just the same as saying a to the n times n. So here's an example. We've got a squared brackets squared. So that's exactly the same as saying a squared, which is a times a, multiplied by itself. So a times a times a times a. And we see that that's just 1, 2, 3, 4. That's a to the power of 4. So that's a squared, and that's a squared. And a squared squared is just a squared multiplied by itself. And so it has to be a to the power of 4. Now, if we were going to use this index law, we would just say a squared times by 2, or a to the power of 2 times by 2, which is just a to the power of 4. It's a lot less messy. And it's pretty and purple. So let's look at a couple of examples. Here we've got 2a squared cubed. Now, I always put a coefficient in, and the reason why I put a coefficient in is because they're the ones that seem to scare people the most. Because we know our algebraic laws, but when you put a coefficient in, it's just a number. And so this, I like to use arrows here. This is the same as saying 2 cubed and then a squared cubed. It's the same as saying 2 cubed and a squared cubed. So we know that we can work out 2 cubed. 2 cubed is just 2 times 2 times 2, which is 8. And a squared cubed is just a to the 2 times 3, which is 8a to the power of 6. Easy peasy lemon squeezy. Now let's do one that's just a little bit more complicated. If I've got 3x squared squared, that's the same as saying 3 squared and x squared squared. So that's 9, 3 squared is 9, x to the 2 times 2. And now I put multiplied by 2, x squared. So I'm adding or using the other index law we learnt last video. So that's the same as saying 9 x to the power of 4 times 2x squared, which equals, I'm running out of room, I do apologise, 9 times 2, which is 18. X to the power of 4 times x to the power of 2 is just x to the power of 4 plus 2, which is x to the power of 6. Easy. And as an extension of this, we can then look at this rule, which is raising a product of terms to a power. It's exactly the same. And this is why I like to use the arrows, because it's exactly the same for each term. It's the same for the coefficient, it's the same for the first term, it's the same for the second term. And so this is quite easy. It just ends up being 2 cubed, which is 8, a to the 2 times 3, b to the 3 times 3, which is 8a to the power of 6, b to the power of 9. And I've done another cheeky down the bottom. I've written in one that's exactly the same as the one up in the earlier problem, or should I say in the earlier rule, but instead I've made it multiple terms. So that's the same as saying 3 cubed, n cubed cubed, and n squared cubed. So 3 cubed is just 3 times 3 times 3, which is 27. M cubed cubed is just the same as saying n 3 times 3. N squared cubed is n to the 2 times 3. Times by 2n squared m. And let's keep on going. That's 27 m to the power of 9 n to the power of 6 times by 2n squared m. And now we do as before, coefficients times coefficients. 2 lots of 27 is 54. m to the power of 9, look over here, this m doesn't have anything on it, which means it's got a 1. And so m to the power of 9 plus 1 is m to the power of 10. And n to the 6 plus 2, which is n to the 8. We're moving pretty quickly here, but if you're having trouble, please stop the video, go back, have a look again, try different problems, and then use the video as a reference point. Also, please make sure that you copy down these nice big and fire imperative so that when you open up your exercise books, you'll be able to see the important bits. Let's recap. Any term with an index that's then to another power, it's just both indices multiplied together. A to the m brackets n is a to the m times n. And it doesn't matter how many terms we have, every term is multiplied by the power outside the bracket. Okie dokie!